Hello and welcome to another GCSE revision video, and in this video we're going to be looking at Pythagoras' theorem. Pythagoras' theorem states that the square of the hypotenuse of a right-angled triangle is equal to the sum of the squares of the other two sides. So if we have a right-angled triangle where the legs are labelled A and B and the hypotenuse is labelled C, then c squared is equal to a squared plus b squared. There are actually a great many proofs of Pythagoras' theorem, but the most famous proof involves four identical right-angled triangles. We can arrange the four identical triangles so that the hypotenuse of one touches the hypotenuse of the other. The empty space forms a square of length c. Now if we lay down the boundaries of the big square so that we can keep a track of it, we can note that the difference between the area of the four triangles and the area of the large square is just c squared. That is to say, c squared is the area of the white space in the middle. We can rearrange the four identical triangles so that their hypotenuses are touching, and the missing space is now a squared plus b squared. And while we're on the subject of noticing, the area of the four triangles is 2 times a times b. So each triangle's area must be 2ab over 4, or a half of a times b, or a half base times height. Another thing you might notice is that the area of the big square is a plus b all squared. That is to say, the length of each line of the big square is a plus b. So this can work as a visual evidence that a plus b all squared is a squared plus b squared plus 2 times a times b. The most important takeaway from this, though, is that c squared is equal to a squared plus b squared, which was the theorem that we set out to prove. Okay, well, so much for the theory. Let's have a go at putting this into practice. I've got a right-angled triangle here, and one of the lengths is 3 units, and one of the lengths is 4 units. So we're going to try and find the length of the hypotenuse here. And so Pythagoras' theorem tells us that let's call the hypotenuse c. So c squared is equal to, let's call this a and this b. So c squared is equal to a squared plus b squared. So c squared is equal to 3 squared, because a is 3, plus b squared, which is 4 squared. So c squared is equal to 9 plus 16. So c squared is equal to 25. So c is equal to the square root of 25. Only the positive root matters because we're talking geometry here. You don't get a negative length. So c is equal to 5. So c is 5 units. This is actually a special type of triangle known as a 3-4-5 triangle. If you have a triangle with one length as 3 times n and the other length as 4 times n, then the hypotenuse will be 5 times n. So this works with any triangle. If this length had been, say, 6 and this length had been 8, then the hypotenuse would have been 10. Or if this length had been 9 and this length had been 12, then this length would have been 15. So the ratio of a 3, 4, 5 triangle will always be the same. If the two legs are, one is in the ratio of 3 to 4, then you know that the other, or the longer length, will be that multiple of 5. So this is called a 3, 4, 5 triangle. Okay, so let's try another example. This time we're given the hypotenuse and we're given one of the legs. So let's label them A, B, C. Whoops. B, C. Okay, so we're told that C squared is equal to A squared plus B squared. That's Pythagoras' theorem. But we don't want to find C squared, we want to find A squared. So if we subtract B squared from both sides, we've got C squared minus B squared is equal to A squared. So let's fill in the numbers. So 17 squared plus 15 squared, that should be a minus. Don't know where that plus came from, it had no right being there. Is equal to A squared. Okay, so 17 squared, let's just do a bit of long multiplication. 17 times 17. 7 times 7 is 49. 7 times 1 is 7, plus 4 is 11. And so 17 times 10 is 170. So 9 plus 0 is 9, 1 plus 7 is 8, and 1 plus 1 is 2. So 17 squared is 289. Now we've got 15 squared, so that's just 15 times 15. Well, 5 times 5 is 25. 5 times 1 is 5, plus 2 is 7. Put a 0 down. Well, we don't really need to put a 0 down. 10 times 15 is 150. So that is, well, that's a 5. 5 plus 0 is 5. 7 plus 5 is 12. And 1 plus 1 is 2. So that's 225. So now we've just got 289 minus 225. Well, take 5 away from 9 and we've ended up with 4. 2 from 8 is 6, 2 from 2 is 0, so that's 64. So A squared is equal to 64, and we know that the square root of 64 is 8. Okay, let's do one more, and in this case let's label them A, B, C. In this case it's the other leg that's missing. So again we've got Pythagoras' theorem says C squared is equal to A squared plus B squared. So this time we have C and A, but it's B we're missing, so let's subtract A squared from both sides of the equation. So C squared minus A squared is equal to B squared. So C squared is 13 squared, a squared is 5 squared, and that's equal to b squared. Well, 13 squared is 13 times 13, which I happen to know is 169, but I'm going to pretend I don't. So 3 times 3 is 9. 3 times 1 is 3. And then 10 times 13 is 130. Add them up and we get 169. So 169, and we already know from our squares up to 100 is that 5 squared is 25, and that's equal to b squared. So 169 minus 25, well, if we take 5 away from 9 we get 4, and 2 from 6 is 4, and then we've got a 1, so that's 144. Which is equal to b squared. So b is equal to the square root of 144, which again we know from our times tables is 12. So b is equal to 12. They won't usually come out with nice whole numbers. I actually chose them so that they would come out nice, so they wouldn't be a distraction from Pythagoras' theorem. But that's how we use Pythagoras' theorem, so that if we have a right-angled triangle and we know any two lengths of a right-angled triangle, we can very easily find the third length. Okay, I hope you found this video helpful. If you did, don't forget to like, comment and subscribe. If you are taking your GCSEs this year, I'd like to wish you all the best with your revision and all the best with your exams. And I look forward to seeing you in another video.